Hi guys, hope you're all doing good today. Before I start, I just want to mention a small thing right here. If you ever declare a variable as a double and store in it a value of an integer like this, it's totally fine. It's going to accept it, the compiler is going to run and it's going to work and everything's going to be okay because there's no difference between 3.0 and 3 in calculations. The only thing that is different is it appears to be 3.0 or not, and it varies from version to version. But if you try to do int x equals some type of double, some versions of programming languages wouldn't even accept it. It'll just give you an error. In this case, it'll take it, but it'll just take off the 0.4, which you don't want that to happen anyways, right? So like if we just had the cout right here and put x, you'll see that it'll right here debug it and it'll just print out 3 for you, right? As you can see right there. So we don't want that to happen, so just never do this. Never declare a variable as an integer and put in it a value of a double, okay? Anyways, let's start with our tutorial for today. We're going to be talking about CMath. Now CMath is a library. It's just like string, and we're going to include it today. So include CMath. Okay, so what CMath has, because it's a library, right? So it has different functions, different mathematical functions. One of those functions is POW, and POW stands for power, right? So POW basically, it's right here. So let's first have some variables ready, double x, y, and actually give them some values. X equals 2, and y equals 4. Okay. Now, POW is basically a function that accepts two doubles, right? So you can put x and y like that, in that order. That's the syntax for POW, okay? POW is a function that is already made and saved into the CMath library, okay? So you have to stick with the way we write it. So POW, parenthesis, with any function you're going to have parentheses and you're going to have parameters, and the parameters of this function are x and y. So what this does is basically it's basically x to the y power, okay? That's all it is. So if you want to see out this, so see out POW xy, it's going to see out x, which is 2, to the y power, and y is 4, so 2 to the 4, and that's what it does. So basically, let's see if that's what it did. Okay, we have errors, missing semicolon before this. Yeah. That's what I love about programming. I mean, it's all easy to debug, and again, I do this on purpose. You know, I make these mistakes so that you learn. 16 right there. Okay, so 2 to the 4th, yes, that is 16. Okay, great. And yeah, that mistake was not on purpose. I was just kidding. Okay, so let's see here. If we wanted to add 1 to that value, we can just do that, right? Because this right here, it's better to always put it in like parentheses to make sure that you're getting this whole entity here in 1. I just like to do that because it looks like all in the parentheses and everything else is going to happen after that. Because remember, our like rules of precedence start with the parentheses, so it's kind of like that. In this case, it's not going to make a difference, but you know, I just got used to putting parentheses everywhere. Okay, so if we add 1, it's going to see out 17. It's just like another variable. That's how you can use this POW here. You can use it for anything you want. Okay. Now another function is the ABS function. The ABS function is basically the absolute value function. If you put ABS of any double, okay, it gives you the absolute value of it. So let's say y was -4, defined as -4. And you put y here, and you can actually put the -4 here. Okay, it's okay. I'm just trying to use variables. Okay, so debug. Let's see what happens. Let's take off the 1. Okay, debug and start without debugging. Yes. Okay, So you can see that it gave us the absolute value of the y, which was 4. Okay, now if you put 4 in the absolute value, it's going to give you 4, and you know that's a known function. It's just math, right? This is just the syntax of how like C++ does it. So you have cosine, for instance, of the like a degree in radians, and you have a lot of functions. The log function, log. So you have several mathematical functions, okay? And we can use all these functions integrated with anything we want. We can use, we can add, subtract. We can use them as if we're using a number or a variable, okay? So this log y can be used as, we can actually make it a variable. We can say define double as z, and or actually just put it on the same line. So double z equals log y. See, now it has become a variable. So you can see that we can just use it as a variable, so C out z like that, We can even actually have the user enter values and then try to, use those values in mathematical functions like this. So like say cin y, okay? Now he's entering something, and what we're going to do is basically get the let's say the absolute value of it, okay, and C out the z, right? And let's put those brackets right there. Okay, so you can do anything you want really, and now this will just give you the user's gonna put in a number like say -9, and we're going to print the absolute value, which was 9. You can do anything you want. Have fun with it. Remember that this library is C math, and we have to include it anytime we use any kind of mathematical function like this. Not anytime we add, subtract, divide or multiply. No, anytime we use these functions like ABS, power, log, cosine. There's a lot of them. I'll leave a link in the description of the video, and you can find like a lot, like a billion, not a billion. I always say billion, but you can find a lot of functions. Okay, well, watch my next video, and yeah, we're gonna do some more stuff, some more cool stuff. Bye.